Mini Lesson 2A, Function Composition. Skill. I could compose two functions given graphs, tables, or equations. What is function composition? The composition of two functions, f and g, denoted as f of g, is defined as f of g of a equals f parentheses g parentheses a, where the value of g of a lies in the domain of f. The input is g of a, and the output is f of g of a. Composing functions from graphs. Evaluate g of f of -1. So this will be the first input into the f graph. So when x is -1, we look at the graph, the y is -4. So we'll say that f of -1 equals -4. And then we'll find g of -4. Find -4 is going to equal -5. So the final answer is -5. Composing functions from equations. Given the definitions of f of x and g of x below, find the value of g of f of -7. We have f of x equals -2x minus 13, and we have g of x equals 2x squared minus 6x minus 10. You want to evaluate the inside function first. This can be written as g of f of -7. So we're going to find this first. Wherever you see an x in the f formula, you're going to plug in -7 instead. It gives you 1. So now we're going to find g of 1. Plug in a 1 into the x for the g formula. So that means that g of f of -7 equals -14. Given the functions f of x equals 3x plus 2 and g of x equals x squared minus 5, determine the values of the following compositions of the functions. Okay, our inner function, we want to find g of 2 here for f of g of 2. It's -1. The outer function, we're going to find f of -1. Our answer in this case is still -1. All right, g of f of -3, the inner function is f of -3. -7. And then we're going to find g of -7. 44. G of 3, we're going to use the g formula twice on this one. It's an iteration. We'll find g of 3 first. gives you 4. And then now we're going to find g of 4. And that gives you 11. On the last one, we have f of x. There's another iteration where you use the f formula twice. But we're going to still have a variable at the end. F of x is just 3x plus 2, which was our given. And now we're going to plug in f of 3x plus 2 into the formula. So instead of x, you put the whole expression 3x plus 2 in there. And then distribute and combine like terms. Let's go to the last page. Composing functions from tables. Find h of g of -7 in simplified form. First, we want to find g of -7. That one we want to look at the table. The g formula is the table. When x is -7, the output is 7. So then we're going to find h of 7, and we'll use the equation for this one. (33). Mixed representation examples. The functions g and f are represented in the table and graph respectively. Use the two functions to evaluate the expressions. If it is not possible to determine the value of the expression, explain why. When we see this notation right here, it means that the g is now the input. It's the inverse. On part A, we want to say that the 12 is the g, what's the x? It is basically saying if g equals 12, what does x equal? Looking at the table, when g is 12, the x is 2. So the answer for this one is 2. On part B, it says f of g of 3. G of 3 equals 1. And so f of 1 equals -1. On this one, we have g inverse of f inverse of -2. Basically, if f equals -2, what does x equal? So find -2, and it looks like the x value is 0. Then we're going to say, if g equals 0, what's the new x? The new x would be -1 here. On D, we have f inverse of 0. When f equals 0, the x equals -2 or 2. And then E, we have g of g inverse of -6. So g equals -6, x would equal 1, and when x equals 1, g would equal -6. Basically, if you have an inverse and a non-inverse, those cancel out. Now on part D, you would not be able to determine which one it is out of -2 or +2. Since they both have the same output value. When that occurs, what you need to do to find an inverse function is to restrict the domain so that every output, there's only going to be one output for each of the inputs. Basically, it's going to pass the horizontal line test in addition to the vertical line test.